Hey students, this is your Professor Chuck, and today I want to talk to you about the syntax of TFL. All right, and so TFL is going to be the major logical language that I'll be spending most of the semester with. Right, it's called truth functional logic, and if you'll remember, truth functionality is just that property of a language, what it is basically it's a property of assertions such that if the truth of the assertion depends only on the truth of the atomic components of the assertion, then it's truth functional, right? So it's very much a kind of a parts to whole relationship where you break down to the atomic parts, figure out whether the atomic parts are true or false, and then you'll be able to understand, however the parts are arranged, right? Then you can figure out the truth of the whole, right? We saw this in CL and CL star. Those are truth functional because we were using the very basic kind of indicative if-then assertions, right? So the if-then style statements, right? Those are truth functional because if you know whether or not the antecedent is true or the consequent is false, right? Then you can know it's false, right? Otherwise, it's true in all other cases, right? Now that's just if-then statements for those languages. In TFL, we add some more. So we're going to be making sense of not statements, and statements, or statements, and if and only if statements. All right, so let's go over the syntax of TFL, get the recursive definition up there. All right, so we're going to be using predicate letters again to name predicates. All right, so there they are in the uppercase, A through M. Anything beyond that is not allowed. Okay, that's just the way the book is written, right, if you're wondering. We also have the lowercase letters A through M. Those are going to be the names for the names. Okay, so those are indicate the objects that are going to be in the extension of the predicates. Again, you can't go past M, right? We have three different kinds of brackets that you can use, right? You can use the regular parentheses that you're familiar with, and the square brackets and the curly brackets. And then in addition to the arrow, we have 5 operators. Okay, so there you have this funny looking thing here. It's the squiggly line. It's called a tilde, right? That's what it's called. We have an ampersand and a ring and a double arrow. All right. Got the window open here and a train is blaring. Excellent. Okay. All right. So first rule here is that any predicate followed by a finite number of names is a well-formed formula. Okay. So here it's a finite number of names. You can't go on forever. All right. It has to come to an end at some point. All right. Then P and Q are going to be just any of the formulas of TFL. So whatever you come up with, right? P and Q again are just being used as variable letters, right? So whatever formula you can generate with the rules here, then each of the expressions, this is going to say tilde P, and then we have P ampersand Q in brackets, and you can use any of the brackets here. It doesn't have to be the parentheses, okay? Or you have P ring Q in parentheses, P arrow Q in brackets, excuse me, and then P double arrow Q in brackets, right? Those can be well-formed formulas as well, right? And then nothing else is a formula. Okay, so this is your recursive definition. You have to consult this when you're being asked questions about what's well-formed and what isn't in TFL. Now let's take a look at the well-formed formulas of TFL and what they might look like. Right here we have C as F. Right here we have a conditional. All right, where we have a 2-degree predicate being the antecedent, right, and this predicate here the consequent. And this one here we're using the different kinds of brackets, right? We have all 3 brackets present, okay, and the main connective is a biconditional. Okay, those are all good. These are not, okay, because P is not part of the alphabet, so you can't use that. We're missing brackets here, and the problem with this one right here is that we're missing parentheses around, a pair. We don't know what the main connective is inside of these brackets here. Okay, so we're missing some brackets. It's important to have brackets arranged correctly because they can make a difference in meaning. All right, so if you're lacking brackets here, we actually don't know what this says. Okay, it's ambiguous. So once you put brackets in, suppose you put it around the ampersand there, right? You put them around this pair, then it becomes an if-then statement, right? So now you have a conditional where this is the antecedent and this is the consequent. However, if you put the brackets around the arrow, right, now this becomes an ampersand statement, an and statement. Okay, and so it's just a totally different semantics now about how you interpret it. Okay. Keep in mind, brackets only go around operators that connect two well-formed formulas together. All right, so ampersand, ring, arrow, and double arrow make use of brackets, but the tilde does not, because that's only modifying one formula that can be connected with these types of things. Okay. If you see something like this, that compound, this not FA here, that counts as a compound formula. Okay, even though it's not connecting like two things like up here, there is a modification, and so that modification counts, as two different things. There's the formula and then the operator, and so that counts as a compound formula. No brackets are needed for tilde things, even if you keep like having more and more tildes added on. All right, and I should also say too that the main connective of something like this is the outermost tilde, always. So this one is the main connective here, and in this case, the main connective is the one right here, okay? And so on and so forth. Suppose you were to have like 16 of these, right? The outermost one would be the main connective. All right. All right, let's talk about conjunctions and how we represent them and how we translate them into TFL. All right, they are represented by the ampersand. Right, the most obvious type of conjunction are the and statements. So, think of John as large and in charge, right? So what you do when you translate that is you actually use John's name twice, because in English, even though it's being only mentioned once, it's being used twice because we are attributing largeness to John and we are attributing in chargeness to John. So that's how I kind of translate things with the predicates. There's the large predicate and there's the in charge predicate. Okay? Now the assertion is truth functional because if John is not large or not in charge, then it's false. So both things got to be true, right? Conjunctions are kind of demanding that way. Right? I just said that. Okay, good. All right. The other thing you got to know is that the ampersand can represent the words but and because. So conjunctions go beyond just the term and, right? If you think of the claim, Kramer is crazy, but Elaine is kind, you have to say two things that are true. Okay? The assertion is true, truth functional, because if Kramer is not crazy, or if Elaine is not kind, then it's false, and you won't be able to make your comparison and contrast. So even though your purpose is to do a comparison and contrast, you are uttering a conjunction because you have to say two things that are true in order to make the comparison. Same thing with like because, that's also a conjunction. So the statement, the boss is late because he missed the cab, right? So I'm translating that, the boss being late, and the boss missed the cab is named there, right? That is also truth functional, okay? Because if the boss is not late, or if he did not miss the cab, the assertion is false, all right? So I know that what you're doing here is that you're giving an explanation for something. But of course, explanations have two parts. There's the part that needs to be explained, and then there's the explanation that is given. All right, and both of those have to be true in order for the claim to be true. Okay, and so it's a conjunction. Those two things have to come together. Let's talk about negations. At the most fundamental level, negations are just denials of what's asserted. Now, there's different ways of doing this. Obviously, we could do it this way. We could say, somebody might say Steven Seagal is a good actor. Now, I don't know if you know who that is. He was kind of a kung fu 80s movie star that I grew up watching on cable television. Right, so if you don't know who that is, well, you can find him on YouTube and have a laugh, right? And, so A says that, B says, no, Steven Seagal is a bad actor. And so what you could do here is you could deny what's asserted by, taking Seagal out of the extension of G and putting them in the extension of B. Right? That's a way of doing this, okay? But we have a way of representing this more directly, okay? You might think like, well, how would you translate this? Right? A replies, well, Steven Seagal is not a bad actor. Okay, what you can do there is actually invoke the tilde, right, and just negate directly the claim by B, right? And so that's what we're going to be doing. Right? That's how we're going to be translating these sorts of things, okay? So when you have a claim like not P, or it's not the case that P, or those things in English like, think of the word like incompatible or unmarried, right? The negation is built into the word, right? And so you can represent that, right? Another thing you can do is, like identify negations with the falsehood of an assertion. So P is false. All right, so then not P, okay? That's a way of translating it. Disjunctions, these are or assertions, and they are represented by the ring. Now, one of the problems we have in TFL is that we have to make a decision because the word or in English is ambiguous. It has an inclusive sense and it has an exclusive sense. All right, so here's an example of an inclusive. George is a liar or a lunatic or both. Okay, so these two categories are not mutually exclusive, right? He could be both of them, right? He could be one or the other, right? So he might not be one or the other, but he could be both too, right? It's a possible. So that's an inclusive sense. Now you have to excuse me, I wrote this in 2016, and I don't know, I think it's still pretty memorable and it kind of makes the point, right? Here's an example of the exclusive or is that either Hillary or Bernie will be the Democratic nominee. Okay, so you can't have both in that situation, right? Only one person can get that job. So what we're going to do with TFL is always use the inclusive or. Okay, so the ring will correspond to an inclusive or. So when we translate a sentence like George is a liar or a lunatic, right, we'll write it like so. And the reason I bring up this example is just because notice how both liar and lunatic make use of the letter L, but I can only use the letter L once to map onto one of these. Otherwise it would be ambiguous, okay? And so I use I here to indicate liar to distinguish it from the lunatic, okay? Now it's truth functional because if he's neither a liar nor a lunatic, well then the statement's just this false. And it's true if he's one or the other or both. Now what do we do with our exclusive or, right? What happens if we want to translate this? Well, we can actually make use of some of the other components we've already looked at, right? We can make use of the conjunction and the negation sign. So the main connective here is still an or symbol, but notice how each of the disjuncts are worded. So this is saying either Hillary will be the nominee and Bernie won't be, or Hillary won't be and Bernie will be. All right, so that is describing, right, the exclusivity, right? So one or the other, but not both. And so you can use what we already have to analyze that. We don't have to introduce a new symbol, all right, to represent exclusive ors. All right, it's truth functional because the statement will be false if both are the nominee, and I'm not sure what kind of world that would be. That would be an interesting world. It's not our world. Or both aren't, right? So suppose somebody else comes along. And then, of course, it's true if only one or only the other is. All right, let's talk about biconditionals. Okay, a biconditional. Well, let's give you an example, right? So here you have a biconditional. Joe is a bachelor if and only if he is an unmarried male. And that's just obviously true, right? Here's a way of representing that. Now notice, right? I mean, the biconditional is just representing the if and only if part. Joe is bachelor. But notice how I use the tilde to kind of represent that un part of the married predicate, okay? All right, so you have to remember that biconditionals basically are just a conjunction of conditionals, right? So we could actually do away with the double arrow and get by with the ampersand and the conditional sign, but this is just going to make things a little more economical for us, right? So we have a double arrow. Here are the two conditionals that I'm talking about. The first one says if Joe is a bachelor, then he is an unmarried male. All right, so we're moving from bachelorhood to unmarriedness, okay? The other one says that Joe is an unmarried male. If he is one, then he is a bachelor. All right, so here we're moving to unmarried maleness, right, to bachelorhood, okay? So the deal is that these stand and fall together. We would speak falsely if one is true and the other is false, right? So a good example maybe of a false biconditional would be this, is that Joe is a bachelor if and only if he is male. That's false because one can be a male and not a bachelor, like me, right? I'm not a bachelor, I'm a husband, okay? I'm married. All right, so you might be wondering, why do we say if and only if? Right? What's the point. I used to, this always puzzled me when as a logic student. I always kind of thought this was logic teachers kind of just pounding their fist on the table and really speaking with emphasis, but it's not the case. It actually represents the fact that biconditionals are a conjunction of conditionals. And if you see that in English, you see the word if here, that's a conditional, and only if, that's a conditional too. Okay, now here's the deal, right? We could say it this way: Joe is a bachelor if he is an unmarried male. And that does represent this particular form, the M to B form, right? Now what's happening in English here is that the consequent is being mentioned first, and then the antecedent is being mentioned second. That's what's happening in English when you use the word if all by itself, okay? And if you think about it, that's right, because what this is basically saying is that if he's an unmarried male, then he's a bachelor, okay? Now in English though, we can say, well, Joe's a bachelor if he's an unmarried male and mention the consequent first. Okay, so you have to kind of pay attention to this weirdness about how conditionals work. Here's where it gets really weird though, right? Is that it's just completely backwards when you say Joe is a bachelor only if he's an unmarried male. So here's what's weird, right? You can see that, Joe's bachelorhood is being mentioned first again in English, just like it is up here. And his unmarried maleness is being mentioned second, right? Just like it is up here. But it's backwards, right? This part now is the antecedent, okay? And this part is the consequent. You might be wondering, well, what the heck? Why do we say this? Why does it look like that, right? Here's the thing with only if claims, right? Only if claims are talking about what's necessary for Joe to be a bachelor. Rather up here, what's sufficient for Joe's being a bachelor is his unmarriedness. And sufficiency is different from necessity. Okay, so this is talking about what's necessary for him to be an unmarried male. Because suppose he's married, right? Then he wouldn't be a bachelor, right? And so this is just a funny thing. This is a weird thing about the way conditionals work, right? Usually what the antecedent's job is to do is to name a condition that is sufficient for the consequent, okay? And the consequent is to name a condition that is necessary for the truth of the antecedent. Right, so there's different ways you can represent this, okay, in English. Conditionals can be asserted in English in a lot of different ways. So let's just kind of look at the way, the old kind of CL, P arrow Q, right? You can say that in the traditional way that we've kind of been talking about, right? You can say that if P is true, then Q is true, right? And so that's a way of stating in English that P is sufficient for Q, okay? So the antecedent's being mentioned first there. Here we're saying Q if P. Now what's being mentioned first here is the consequent, but notice the way the if is being used there is that it's indicating to the reader that P is sufficient for Q. Okay? Same thing here, Q, provided that P, all right, P again here is sufficient for Q in English. Same thing with Q given that P, right? But when we say P only if Q, we're saying something completely different now. We're actually saying that Q here is necessary for P, and so the antecedent's being mentioned first, right? It's a really kind of a strange thing, but you need to understand that, all right? It'll really trip you up if you don't pay attention to this, right? The big idea is that P is sufficient for Q if and only if Q is necessary for P. That's how sufficiency and necessity relate to one another. Okay? All right, so let's talk about just the practice problems. You can kind of do these on your own. They're pretty simple. You're just trying to figure out what's well formed or not, right? Here's the answers. You can take a look at that if you'd like, right? Those are just pretty simple. And these practice problems, you're just trying to find what the main connective is, right? And so the answers are there for you in the slides. Okay, you can take a look at those. Those are pretty simple and straightforward. And then in these, right, what we're going to be doing is translating a little bit, right? We got to get practice translating, okay? And so here you're given some, predicates, all right, and then here's some examples on how to do this. And then you have some answers, Okay, you can kind of take a look at how those work. All right, so that's the lecture. And if you have any questions, just let me know, and I will talk to you later.